Hello everyone, it's been a long time. I haven't made any videos. I think my last one was from January last year. Um, I've been busy with work, so um, Sol-1 was off for the last year, and last month I decided to go back home and I brought it here to where I'm living now. And I also continued working on the compiler, the C compiler for it, which I made a video about last year. So the first thing is on the CPU is on right now, and fortunately there were no problems with static electricity, carrying it from one city to the other. So yeah, it's intact and running fine, just as it was before. Just the domain sol1.org right now is off. I need to reactivate it. Okay, so everything is as it was before, except that for the past month or so I've been working on the C compiler for it, making it more complete, adding more features of the C language. And right now I think it's in a very good state. There are bugs and there are things that it will error if you try to parse, but yeah, many of the features of C are implemented. Pointers of any level and matrices of any dimensions are working. And yeah, I don't have structs yet. I will implement structs next. I have implemented enumerations, so enumerations work. So right now let me log on here into Sol1. So this is my local network, so it's still connected to the Wi-Fi, so I can connect here via my laptop on a telnet session. This is just not on the domain. So okay, where do I start? So if we remember, so this is the Unix-like operating system that I started writing. It's really a baby operating system. It's not it's far from complete, but I have the basic directory structure and everything. It's just not, of course, it's not yet Unix compliant. It doesn't have inode tables and a bitmap to tell the free blocks and everything. Right now, it's each file is 64 bytes long, and that's it. So anyway, so that's if I created a folder called CC for the C compiler. So I was while testing, I just wrote a few programs and compiled them and run everything here. So if I do, let's first remove all these old programs that I have here that I was testing, except this one. This IVO is very long, and I have a problem with the Wi-Fi board. Sometimes it receives and sends garbage characters. I think it's to do with the voltage translations, or maybe it's something in the code. I just copy some telnet code from the internet, and I put into it. It's the ESP8266, so it's hosting a telnet server and then communicating with the computer via the computer's serial port. But yeah, sometimes it's buggy. So if I paste a program that is too long, it could contain errors, and then I have to try a few times until I get it right. So I'll leave that one for now. So I'll remove these other ones. Okay, so let's try. Let's go through a few programs, C programs that I wrote, and then we can take a look at the assembly that it generates. So yeah, first of all, the code for the compiler itself is here. It's all here in a single file. So yeah, it's about 3,000 lines long. It's not very big, and it's a kind of ad hoc compiler, so it's not I'm not using syntax trees or anything like that. It's a recursive parser basically, and it will go into each function that you write and then start parsing the block, and for expressions it calls each level of the expression recursively. So yeah, it's a recursive parser. And okay, so this program is just to calculate a factorial. If you notice on the first line I have this inc asm directive. So this is not a C header, this is a direct injection of assembly code, an assembly library that the assembler will later use. So the compiler will parse all the C code, generate the assembly, and this just tells the compiler to add this file at the end. So yeah, I don't have C libraries yet. Any C functions that I need to use, I need to write them as a combination of C and inline assembly. So for example, this print function is here declared as a C function here, which takes a char pointer, and then I have some inline assembly to actually use an assembly function that prints the string. So yeah, we can declare local variables, etc. We just cannot assign them for now, so we can't do, for local variables we cannot assign them straight away like that. We have to assign in here, like n equals 3, etc. I will fix that later. So yeah, we print factorial, gets a number, and then get the factorial of the number and assign that into the result, and then print the result. So it's a very simple program. It's just to demonstrate recursive functions. So factorial of the number, if the number is equal to 1, you return 1. Otherwise you return n times the factorial of n minus 1. So it's calling the function recursively. And so if we go into if we open a terminal and I cd into the compiler directory, I have this shell script that will compile the C file, and then we'll call the assembler to assemble that into a binary file. I do not have my own assembler. I have not written assembler yet. I will write, probably will maybe have to write one later, but for now I'm using TASM, which is an assembler where you can list a table with your instructions and how much data they take, how long the instructions are, and then it just works fine. But it's a DOS program, so I have to use that through Wine. So we just do /compile.sh and then the program name, let's say facts.c. So first it compiles my compiler with GCC. I just added that so I don't have to, I can just run this even if I change the compiler itself. So it compiles my compiler with GCC, and then it uses my compiler to compile the facts.c. It generates the a.s, which is a text assembly file, and then it compiles that into a binary with TASM. So that's compiled, and here we can have a look at the generated assembly. So this is assembly for the Sol-1 CPU. So we have just a comment here with the file name. We have included the kernel, some kernel exports, so we know the numbers for and the mnemonics for the system calls. It just does .org and then begins text. So this is the main function, this one in C, and then it just the compiler generates the assembly for everything. Generates the assembly for the fact function and all the other functions that we have, print, etc., get n, and then the global variables are declared at the end. So if you notice, we can print strings directly, just like in C, and the compiler will take care of that. We'll declare them at the bottom here. We'll assign them an address, and whenever you reference the string, it will add the address correctly there. So after running that script, the script that also copies the output object file into the clipboard as a hex Intel hex format, and then we can come here and do a make bin and the program name that will allow us to create a binary, and then we just paste the Intel hex in there, and that creates the file. And now we can run that factorial. So yeah, factorial of, let's say, 6 result 720, which is correct. Let's try a factorial of 7. Oh, let's see, I just added an argument. I ran it incorrectly. So yeah, just fact, and let's say 7, and Not sure if that's I can't remember what the factorial of 7 is. So if we take 720 times 7, so 540, so yeah, that's correct. So factorials grow very quickly, and this is working on 16-bit numbers, so you can't go above yeah, 8 in this case. So yeah, it's just dealing with 16-bit numbers here. So let's see the next example. I have this program, but a friend of mine, Nino, he's got a YouTube channel. I asked him to write me a fun C program that I could use to test the compiler with, and he was very helpful and wrote this very nice and very interesting fixed point arithmetic calculator that takes two input numbers as fixed point numbers, and then does basic arithmetic with them, like adding, subtracting, multiplying, and dividing for all the operations, and prints the results. So it's quite a long program, as you can see, and I had quite a few bugs trying to run it, compiler bugs. So this program was very helpful into fixing bugs in the compiler and rounding it up. So if we now compile this one, large numbers, etc. So compile that, and the C program itself is very long, as you can see. It's about 1,000 lines, but the assembly generated is huge. You see, it's about almost 9,000 lines, which in part is due to the fact that my compiler is quite inefficient. I need to make it more efficient later, but at least it compiles. So the purpose of it was to actually compile C correctly, but yeah, it's inefficient. So I have to look into that and make it more efficient. There are many things which are very basic to fix. In places, for example, it will do a push A followed by a pop A, for example, things like that. So I could just reparse this and remove duplications. Yeah, and other things that can be optimized. So yeah, so that's that, and then because I didn't delete it previously, I still have it here. So if you run that, so it prints. I think that's the first two numbers. Oh no, it's just, I think it just prints loads of zeros just as a prompt, and then we can enter the numbers. So let's say he gave me a recipe to try, which is 0 0 0, and then 1 2 3 4, 1 2 3 4, and then 5 6 8 5 6 7 8, and then 0, and then print 0 again, and then that's ask for another number, which if I remember right was 0 0 2, or it might be 3 4 5 6 7 8 9 0. Yeah, and then 0 again. So yeah, it takes the numbers like this, which I think yeah, this part is the integer part and this part is the decimal part, if I'm not mistaken. So we enter the numbers in that format, and it does the addition, subtraction, division, as multiplication and division, which if I think if I look here, there's somewhere he sent me that. So 0 0 0 1 2 3 4 5 6 7 8 0, and then 0 0 2, etc. Yeah, so these should be the results, and if we look here, you get, the first one is correct, second one is correct, third one is correct, and last one is correct. So yes, yeah, that's a very nice program, and thank you, Nino, for that. That was very helpful, and I hope we can work on that and try to make it more fun, so we could enter decimal numbers, enter the integer part followed by a dot and followed by the decimal numbers. So the next one I wrote as an example was the game of life, Conway's game of life. So in this one I have a 40 by 40, and then I initialize the array with a few structures. So this is a glider gun, it emits gliders, and these are just two oscillators. So yeah, this is the program for that. So this checks if the cell is alive, this displays the grid, this counts the neighbors, the number of neighbors, and these just print functions. So then this is the main function. So if we compile that one, so life.c, compile that, and again this is the result. So as you can see, this is the global data for the array initialization, which in this case is printed as hex numbers, and then we have the assembly generated. So as you can see, for local variables, int I, j, we're doing sub sp 2 for 16 bits integers. So as you can see, we are doing 3 subs, which is inefficient. An optimization would be to do only 1 sub with the total size for all the variables. But for now, that's how it is. And I have that copied to the clipboard, so we'll make bin life and then paste the code, and hopefully if there are no silly errors with the Wi-Fi board, it should run. If it doesn't run, we can try again. So do life, it takes a little while to initialize, and then it should start printing the grid. Yeah, so prints the grid. It's slow, especially because it's compiled, so the compiler is slow. If I write this in assembly, it's gonna be much faster, but yeah, it's slow, but it does work. So if we just look here for a while, we can see the glider gun moving, and it takes a little while to start emitting the gliders, but we'll see. And as you can see at the bottom, we have the oscillators with a period of 3, so they go in a cycle. This is the first cycle, and then it morphs into the second form, which is this one, and then finally it morphs into the final form, which is this one, and then it goes back to what it was before. So as you can see, the glider guns, they start from the edges and then they come together, form some structure, and then that structure eventually becomes a glider, and then the glider guns go back to the end. They hit the little blocks at the edges, that makes them turn back and meet again in the middle, so it goes like that, goes on like that forever. So here's a glider. Not sure if you're familiar with the game of life, but this is a pattern that will move slowly diagonally like this. So for every steps it changes itself a little bit, reorientates, and then the next step it moves a little bit. So it moves like that, so it's a repeating pattern in the game of life. So yeah, that will run until it meets this thing, and then it will turn into chaos. I added that just for fun. So yeah, Control C to stop the program. And let me see if I have any other interesting ones here. Well, this one is one that a friend of mine made. Augusto made it as a fun test program, which creates a matrix pattern in ASCII. So we can take a look at that and try to run matrix, and yeah, creates a fun pattern, matrix like pattern, fills the screen with ASCII. So yeah, that's cool. Let's see, well, square roots, cat, so we can try the I have a sort test program which sorts via the bubble sort. Also have an integer square root program. Maybe let's try the sort one. So let's compile sort, compile that. Let's go make bin sort, paste, enter, ls sort. So we enter a string, let's say hello world, enter, and then that's sorts the string for us. So yeah, I think that's all I have to show you for now. I don't want to make the video too long, but yeah, the compiler is working quite nicely now. We can do pointer arithmetic, we can do matrix arithmetic, we can have nested loops, ifs, whiles, do while loops, switch, and everything works. Of course, there are bugs that I still have not found, but yeah, when I find them, I'll fix them, and I'll try to implement the structs as well, and then a C library. But yeah, for now I think that's all. The project is on GitHub, so if you go on GitHub, everything's here. I also have a system verilog model for the computer, which is mostly working, I think. Yeah, it's mostly working. It's probably not fully complete, but yeah, if you have QuestaSim, if you download the free version of QuestaSim from Intel, you can run the system verilog model. And I'm trying to tidy up the documentation as well, using ASCII doc. So I'll try to set up documentation for that as well. But yeah, everything is available there. And yeah, that's it for now. Thank you very much for watching. Hope you enjoyed that.